We'll get to that. Great question. So previously we've been discussing how to figure out the charge on an atom. Remember, it relates to the number of protons and the number of electrons. If you look at your periodic table, probably the easiest way to remember what charge each atom in each group forms is all group 1 atoms will form a +1 ion. That's because they lose 1 electron and they're left with a positive. Right? So two atoms are at a bar. One says, I lost an electron. The other says, are you sure? He says, I'm positive. So just think of that over and over again. So then group 3 is +3. Group 5, -3, because it gains 3. Group 6, -2. Group 7, -1. So, what subatomic particle determines the atom? Is it the electron, the proton, or the neutron?
Proton.
It's the proton. It's the proton that says, you are aluminum. You act like aluminum. If you have the same number, so if you have 13 protons, you're always aluminum. So let's look at isotopes. So all atoms of a given element contain the same number of protons. Z is characteristic. I'm like, what is Z? She's never said Z before. Let me define that for you. This is atomic number. On your periodic table, what is atomic number? And it's what color is it?
Red?
Blue.
Mine is red. No, wait, that's chemically, sorry.
Yeah. So remember the atomic number is in blue. So that's what I was just saying. That whatever you are is because of your protons. That's your atomic number. So atomic number is characteristic. The number of neutrons can vary. So what are neutrons again?
Neutrally charged particles, subparticles.
They're neutrally, not neutrally, they're neutral subatomic particles. What is their mass? Do they have mass or do they have negligible mass? They have mass. Electrons have negligible mass, okay? So with mass.
Isn't the mass the same as the proton?
Yes. Exactly.
Quick question.
Mm-hmm.
So atoms are like the smallest building blocks of matter, right?
Mm-hmm.
But there are subatomic particles which are smaller than atoms, which compose atoms.
Right.
Can subatomic particles exist anywhere other than atoms? Can like there be just a floating proton in space somewhere?
For any very small moment in time. They're not very stable. So like these particle accelerators, you can get that, but then it crashes into something else and makes something else.
Okay.
It makes sense. So yeah, you're going to always have these subatomic particles together, unless you're doing some tiny, unstable experiment. Okay, so the number of neutrons can vary. So neutral subatomic particles with mass. So let's look at isotopes now. Isotopes. They have the same number of protons, different neutrons. Same number of protons, different neutrons. Therefore, different mass number.
What are those 3 dots for?
Oh, that's the therefore. The abbreviation for therefore.
Oh. Okay then. Is that in chemistry?
You see it in like math too. It's like a scholar thing.
Gotcha.
Okay, so hydrogen has 3 isotopes. The number of protons are the same, the number of neutrons differ. Which number is affected, A or Z? All right, let me define these. So Z is atomic number. A is mass number. And then mass number is the number of protons plus the number of neutrons. I'll say this a lot more.
So A is the variable.
With isotopes. Yes.
So it's number of protons plus number of protons.
Oh, number of neutrons, sorry. Thank you.
So, just to wrap my head around it, Z, the atomic number would be more like the DNA, and then A would be the variable, meaning if you have blue eyes or green eyes.
Not so much, just wait for me to cover and you'll probably see this better. Okay, so what's the atomic number for hydrogen? 1. Excellent. Okay. So how many protons does hydrogen have? 1, right? All right. If this is a neutral hydrogen, it doesn't say hydrogen ion. How many electrons would it have?
1.
Just 1, right. Okay. So I will have to provide you the mass number. And Tony, your question, I will give you a table like this, and I'll give you like 2 or 3 values, and then you can fill in the missing value. So it depends on what I'm asking you for. Okay, so I'm going to give you this mass number. The mass number for this one is 1, for this isotope. So sometimes you'll see isotope names written hydrogen 1. That 1 is referring to the mass number. And the mass number, remember, of our subatomic particles, the protons and the neutrons are what have mass. The electrons are negligible. Right? All right.
Is that a negative sign?
No, it's just a hyphen and then a 1.
Okay. So it's pretty much like equals. It's like it's hydrogen 1. The next one's hydrogen 2.
Yeah, or
It's
it's
like
like,
their names.
if you've ever heard of carbon 13,
Yeah.
when you see carbon hyphen 13, that's an isotope of carbon.
It's like their names. That's what I'm thinking of.
Yeah. Mhm.
It's like their cousins and hydrogen 1.
Yes. Cousins is a nice way. Okay, so now I told you that the mass number is the number of protons plus the number of neutrons. So the protons plus the neutrons equal this mass number.
So there's no neutrons.
There's no neutrons in hydrogen 1. Now, an isotope of hydrogen 1 is deuterium. So you've probably heard of deuterium, maybe in your biology classes. There's been a lot of things that have been discovered because of these isotopes, because you can follow them. And pretty cool. So the atomic number on hydrogen 2, what is it? It's hydrogen, so it has to be 1. Okay, I gave you the mass number in its name. So what's the mass number?
2.
Mhm.
Oh, so that mass number. Oh, I see.
So the identifier is the mass number?
Hydrogen 2.
Okay.
Now, how many protons does it have?
So
One.
hydrogen
1.
3 is.
How did you know that it had 1 proton?
Yes.
Because that's the same as the atomic.
Yes. So I'm going to circle these. The atomic number is the same as the protons, which is the same as the electrons. So it's one of these stealth things. You have this whole big table that needs to be filled out and you think, oh my gosh, I'm panicking, I don't know what to do, I don't know what to fill in. And then it turns out that the atomic number tells you the number of protons and tells you the number of electrons, and it also, so it gives you 3 spots. Now, the mass number. How can I figure out the neutrons from the mass number? Subtract. So remember that these two numbers plus each other must equal the mass number. So what number do I need here to equal 2? 1. So it's still hydrogen. It still has 1 proton, but it has a different number of neutrons. Then hydrogen 3. What's the atomic number there?
3.
Atomic numbers are 1.
1.
Well,
Good.
mass number's 3.
Mass number's 3.
Okay.
Which one? How's the,
There's
so
two
is the atomic
neutrons.
number 1 because it's just hydrogen?
It's always hydrogen. It's like if I just said an element has an atomic number of 1, you could figure it out. And it's not because you memorize it, it's because you know that the atomic number is the identifier for each element.
So no,
It's kind of like your DNA.
it's like a last.
Mhm.
Other person. I'm just trying to come up with another way to fix this. So then.
Just think of, you can think of like a team of like racers, like if there's like different schools on a track meet, like it could be like Blue Valley 1, 2, 3, 4, and there's another team. So like it's like teams, but then like subsets of a team.
Okay, but they're all frozen.
Yeah.
So they would all be Blue Valley.
So like team hydrogen, and then there's like 6 racers for hydrogen,
Yeah, so we got hydrogen 1, hydrogen 2, hydrogen 3.
and then they're racing with
I think we did that.
Good. All right, so the number of protons in tritium, hydrogen 3, would be what? 1. The number of electrons would be?
1.
What would the number of neutrons be?
2.
2. So these numbers plus each other equal. So, good. So one thing I want to point out is on your periodic table. If you look at hydrogen, there's this number in red. And if you're ever lost on this periodic table, you can always go to the key. And this says atomic weight. I don't ever want you to use atomic weight for the mass number here. Okay, so atomic weight is not equal to mass number. So I'll sometimes have students fill out this table, and they'll fill out like 1.00007876532. You should have none of that on your table. Whole numbers should be filled out on this table. Our periodic table, the atomic weights are an average of the natural abundance of each element. So carbon, if you look at carbon 12, carbon 12 has how many electrons and how many protons?
12.
Not 12, but look at the atomic number, right?
6.
6. So carbon 12 has 6 protons and 6 electrons. So the mass number for carbon 12, I'll just put
Would be
this,
12.
carbon 12, 6 protons, 6 electrons, mass number would be 12. Okay? And then if you look on the periodic table, the atomic weight is 12.011.
But isn't the weight different for each one?
So what happens is that there are naturally occurring isotopes of carbon that are factored in with this periodic table. So there's a lot of carbon 12, but there's some carbon 13 and there's some carbon 14. So it might be like 0.2% carbon 14, 0.6% carbon 14. So that's why it's a little bit higher than 12.
Because
So
they're averaging.
they're averaging. It's kind of like your grade where you have it weighted, like each isotope has a weight with
So-
natural abundance.
So since there's so many 12, that's why it's closer to 12.
Right. So that's why I don't want you to use mass number is equal to atomic number. That's why they're not equal. Okay? I'll say this about 50 more times. But hopefully it sticks. Okay, so a common abbreviation you will encounter is shown below. So let's see. You'll have your element abbreviation, and then remember, what does A stand for? Mass number, and then atomic number.
Why is it A and Z?
Why is it A and Z? That's just chemistry.
Why not do A for atomic number?
Yeah.
I know. So carbon 12. The abbreviation for carbon is C. The mass number is 12, and the atomic number is 6. So that would be abbreviation carbon for carbon 12. All right, let's work on uranium-235. Uranium-235 is commonly used in nuclear reactors. How would you write its abbreviation?
Your capital U for uranium
And it's on the
and
inner transition metals. Yes, the
atomic number would be 92. So that's the lower number.
Yeah.
And then the 235 on top. Those are also transition metals.
So you can impress your friends now. Say, look what I'm doing in chemistry. These fancy symbols. Okay, so on the next page, if an atom with a mass number of 27 has 14 neutrons, it is an isotope of which element? So believe it or not, I have given you enough information to figure out what's going on.
We figured it out.
Yeah, so how'd you figure it out? What'd you do?
Well, I know that if the mass number is the sum of the neutrons and the protons, protons, I can take the mass number minus the neutrons, and that'll tell me how many protons I have, which is going to be the atomic number.
Mm-hmm.
So then I can look up that atomic number, which was 13, and see that it's aluminum.
Okay, good. So silicon, so I'll put Z for all of these, is 14. Aluminum is 13. Cobalt, what's the atomic number for cobalt? 27. And niobium
27 for cobalt.
is 41. Okay. So the only one that matches up with this atomic number is B.
So isotopes basically you just add neutrons to an element.
They have a different number of neutrons.
Thank you.
Okay, so let's work some homework problems that cover isotopes, so we can further solidify this concept.
Do we create isotopes or are they naturally